I'm Preeti, Assistant Professor from the Department of Computer Science and Engineering. Today's video is about the Project and Process Metrics Part 3. So in our previous videos, in Part 1 and Part 2, we have discussed about various software measurements that focused on size-oriented metrics, function-oriented metrics, reconciling the LOC, that is the lines of code, and FP metrics, that is the functional points. And we also have seen the object-oriented metrics, use case-oriented metrics, web app, project metrics. So in our today's discussion, we will be focusing on how to calculate the cost estimation when we already are given with the various parameters that are involved in a software development process. And then we will also be focusing on the Cocomo models, right? So here, what exactly are the size-oriented metrics and the functional points? What are lines of code? Cost estimation. Why do you require cost estimation is our main focus of discussion for today, right? So before we just go to the main part, let us just have a fast recap about what exactly it means by the measurements. That is, here it is already stated that we have two measurements. One is the direct and the other one is the indirect. So when we say direct measures, it is nothing but it's the length of the bolt that you are considering. And when you say indirect measures, it means that you cannot measure them with numbers. It's like you are trying to focus on the quality of the bolt. So when you say direct measures, you have a proper number to it. But when we say indirect measures, we don't have the number, but we generally focus or take them on a scale and put them in some ranges from 0 to 5, 5 to 10, so on. And then we bring out the values from them and then we talk about their efficiencies. Now, when you are trying to focus on how to find out the cost estimation, we will just have to know about size-oriented metrics. Here, our general focus is on how do you calculate the size of a program. As we've discussed in our previous things, how do you calculate the size of a program? It is like you will have to count the lines, removing the comment lines and the white spaces. That gives us the line of code, which is called as LOC. And then we have size of a process, which also allows us to calculate three things. That is the estimation cost, the time scale, the faults that are involved in a process. So initially, you have to know what is the size of the program so that you can concentrate on the other parameters or get the other outputs of the program and focus on how do you trace out the things and where you need improvement, where you don't require improvement. And here, size of the process also allows you to focus on the effort that is put by persons per month and in how much time period and how many errors are you trying to trace them out. Okay, all these things is the main area or it is also a critical area in a project planning. So here our focus is on how do you calculate the LOC and the functional count. To elaborate on these two things, you can define them as it is nothing but it is including all the lines of code along with the headers. That is the program headers, declarations, executable and non-executable statements. So when you ask like what is the length of the program or what is LOC, it is like you have to include all these things that are stated. That is the program headers, the declarations, the executable and the non-executable statements. And this is a very important point where you are not supposed to count them as a line of code. They are the comments, the blank spaces and any other things, something else, and main are the comments and the blank spaces. And when you are focusing on this particular estimation or trying to calculate the cost estimation, you have some advantages and disadvantages along with it. So what makes these lines of code? If you are trying to know the lines of code of a program, what are the advantages that you are trying to talk about? It is like you can estimate them, a proper estimation can be them, and how much code can be developed or how much code will be available. That also is an advantage on it. There are also disadvantages as there are two sides of a coin. For any process or any discussion we do, there will always be advantages and disadvantages. In the same way for this, advantages we have seen, it is trying to use the lines of code for estimating the size of a project. And it is also easy to count, calculate, and develop a proper code, not making it too lengthy, minimizing it wherever the things are not required, and giving them a brief content that is giving us an accurate result. And what are the disadvantages when you talk about the size estimation or the lines of code? Is nothing but it is a language and technology dependent. When you say LOC, it changes from language to language, right? So when you take the any programming language, they might have headers, they might not have headers. So if you are not using any such kind of headers, you can remove some 4 to 5 lines at a stretch, which is reducing the length of the code. So that is a disadvantage and technology dependent. Next, if we use software design which is not up to the mark, then it leads us to more lines of code. It leads us to excessive lines of code. So these are the disadvantages. As I have shown you in the previous presentation as well, there is a program which we've taken. Here, if you look at this small simple program, which is having 16 lines of code, out of which if you are removing this header files and if you are removing this comment lines, it leads you to the LOC of 14. So this is how you calculate LOC and the functional count and the FPAs. So what is this functional count talking about? Functional count is actually trying to provide us a solution of how do you measure a particular problem. So FC is actually a solution for measuring the size measurement of any problem. So the first step is the lines of code. Then our focus is on the FPA or FC. FPA is nothing but functional point analysis. And you can also count upon the number of functions. So it has few special parameters. What are they? They are independent, language independent, and you can have a proper estimation in the early phases itself. And you can directly link them up to the requirements is the third one. And next one is you can, it is actually based on the user's external view, meaning the final end product also, it is trying to give you a picture in advance. So now, moving to the main discussion of today, it is complete focus on the cost estimation. So till now, we have seen what exactly you mean by LOC, what is a functional count, or what is functional point analysis, what do they do to help us estimate something, or what are the things they provide us. So here we start off with our main motive of today's discussion is the cost estimation. So what do you mean by cost estimation, or where is it required? So you can look at the slide which states for software project development, firstly, you require a proper plan. So in my previous videos, we have seen what exactly is a plan, how do you draw a template for a particular plan, what are various process models involved, all these things we have seen. So here we are coming to the calculation section of how do you decide the efficiency of a particular product or a project in a software development. Here comes the focus of the cost estimation. So for any software development, project development, you require a plan, right? What does that actually need? Why do you require a plan? So that you can estimate the size of the particular project, and you will also have to know, once you know the size, you also have to know about the cost, how much time is it taking to develop a particular project, and what are all the resources that are required for the project development, and how are you scheduling them? What is your plan of schedule? All these things are the main focus involved in a plan, and this plan is linked up to the software project development. Right? Now, so when you say cost estimation, what are the things that you need to calculate, or what are the things that you need to know exactly in cost estimation? So whenever you say cost estimation, obviously you are supposed to calculate the cost, or you are supposed to know what is the cost. And the second thing that comes to picture when you talk about cost estimation is estimation of your project. How well can that be executed? So why do you estimate? How much amount of resources do you require? right? If you require too much of resources, what happens? Your cost keeps on increasing. But if your content is not up to the mark, then there is no point in uh, having various resources and putting down so much of cost into it, right? To know all these ups and downs, you have to first know the lines of code, as I told you, that comes under the size estimation, and then the cost estimation. So cost estimation will give us or will tell us how do you have to calculate the cost, and then estimation of the project, and how important it is. That is from the point of the customers. That is how point from the customers, and how much can you charge from them. If they are trying to tell the developer to develop in 6 modules, right, and it's taking too much time, where more number of resources are required, then you can increase the size of the cost. That is, the cost estimation increases. That is nothing but charge from the customers, that is the end users. Next, cost discussed at the initial stages. That is, before you start your project work or before you have initiated your work, that also is discussed in the cost estimation. Next, the commencement of the project. When are you starting? So to know about cost estimation, these are the 5 important factors that have to be noted. I repeat, they are the calculating the cost, estimation of a project, charges from the customers, and how much is the cost discussed in the initial stages, and your commencement of the project or your schedule of the project. So all this will go along with the cost estimation. Yeah. So I have a small diagram which depicts what are the major planning activities for any software development project or a product. So these are the things that you can jot it down. Whatever I have stated in the previous slides, you can put them all down in a diagram in this manner, where initially you are supposed to estimate the size, right? When you talk about the size estimation, it moves to the cost estimation and the development time. So when you talk about the size estimation, it leads to cost estimation and the development time. And these both in turn, how much amount of resources are required. So the requirement of resources is comes into the picture when you are trying to know about the cost estimation and the development time. And this all leads to how do you schedule a project. So initially you have to estimate the size, that is the lines of code. Then how much are you charging, or the customers try to charge the developer. Then how much development time you require. Once these 3 things are framed, that is the size estimation, your cost estimation, the development time, then we have to talk about whether the resources are available. If there are no resources and you are talking about the development time cost estimation, it is of no use, right? So first, are the resources available? Once the resources are available, then you can talk about the cost, then you can plan out in how much time you can develop. All these 4 things finally link up to the project scheduling. Right. Moving further. Now, continuing our discussion on the cost estimation, various estimation techniques have been developed, and there are some attributes that have to be discussed upon, right? So I repeat, whenever you want to develop some kind of a process or a project, there are various estimation techniques, right? Why are we discussing about estimation techniques? Because our main focus of today's discussion is cost estimation. So we have various estimation techniques, and they are having some common attributes, right? So when I say, what do you mean by attributes? If I say a student, so what are his attributes? It can be his surname, it can be his course, and his different parameters. So all those will come under the attributes. So why or what is the main focus of knowing the common attributes that are linked up to the estimation techniques, right? So I repeat, whenever you want to talk about any kind of development project or a project development, you have various estimation techniques. They are having some common attributes, right? And it also tries to discuss or talk about the prior definition of the project scope. Okay. So priorly defining the project scope. Project scope is nothing but what exactly you are trying to deliver. So you are trying to priorly define them. And estimates are also derived from the project metrics. And each project is divided into smaller units and then they are estimated individually. So this complete 4 points is generally talking about the estimation techniques. Why do you require estimation techniques? As I have previously shown you, for any planning activity, for any project planning or a product planning, firstly you should know the size of the project. Once you are knowing the size of a project, you are having the cost estimation and the development time, right? And then you are trying to know whether the resources are available. And then finally you are trying to plan out the project schedule. So basing upon this, we are talking about various estimation techniques which hold some common attributes in common. Why do you require to do? Because it is priorly defining you the scope of a project, and it also derives estimates from the project metrics, whatever has been defined. So whatever project you are talking about, you are breaking them down into smaller units or modules and estimating each module individually. That is, this is an entire project. You are breaking them out into different modules, module 1, 2 and 3, and then you are trying to estimate each one individually. Okay. Now, there are two models that comes under cost estimation. The first one is the static single variable model. The second one is static multivariable model. So these two things will help us to find out the cost estimation. So moving further, let us discuss about the first model, that is static single variable model. Okay. As the term itself is saying single, it has its unique element. So I repeat, static single variable model is the first model for the estimating a cost of a project. Okay. So when you talk about the single variable, it is taken as a unique element for calculating all the other factors like the time and the cost. So this is very, very important definition to elaborate this particular technique. What is it saying? As the name itself suggests, single variable. So this single variable is taking up a unique element for calculating all the other things like the time and the cost. And what else does it do? This variable, whatever you are trying to take, is trying to talk about the size of the project. This is trying to talk about the size of the project. Now, with the help of the size, whatever we have got, we will find out the development time and the cost. So once the size is known, we will be able to calculate the development time and the cost. So this is a complete focus on how this particular model of static single variable model is trying to talk about. Fine. Now, so there are some formulas that are involved in this particular models for us to calculate the things and get the output. Basing upon that only we can decide how efficient our model is. Okay. So first you are being given as a formula, that is C equal to A L to the power of B, where C is the cost, L is the size of the code, and A and B, whatever are defined, are the constants. So to calculate the cost, you are supposed to make a product of A cross L to the power of B. So here A and B are constant, C is the cost, and S is the size of the code. Size of code is nothing but the lines of code. Next, you have E. E stands for effort in persons per month. So for example, if you have some 5 people who are working on a particular module, so how each person, how much effort is he trying to put? That can be calculated by E equal to 1.4 into L to the power of 0.93. So 1.4 and 0.93 are the constants that are specified for the efforts per months. Okay. And the third one is the documentation. So once you are doing up all these, you have to pile up all those things. So that again is formulated in this terminologies where DOC equal to 30.4 into L to the power of 9.0, where D is nothing but the documentation, the number of pages. And you also have in how much time. As I told you priorly, that is, for if you are knowing the size, from the size we will be calculating the development time and the cost. So we have been given C, we have been given effort, and we have seen the documentation and the duration, how much time. That is calculated with the help of 4.16L to the power of 0.26. This is the duration. How much time is the particular project being executed? So substituting the values given in all the above formulas, you get the relevant things. That is the cost, effort, documentation, and the duration. So these four formulas will help us to calculate the various parameters required for the project development. Right. Now, you have the second model, that is static multivariable model. So that was a single variable, and this is the multivariable models. So this, you will be able to calculate these models again basing upon some formulas, which stands cost is C equal to A cross LB, where A and B are constants, right? They are trying to depend on various aspects in an environment. So those aspects can be the user participation, the customer based changes, and the memory constraints. So I repeat, you can calculate a static multivariable model by using by knowing the cost of it, which is C equal to A cross L to the power of B, where A and B are constant. C is nothing but the cost, and these are trying to depend on various aspects. That is, how much is the user's participation, or what are the changes given by the customer every now and then, and what are the memory constraints involved. Okay, so all these are actually the basic things that are discussed in the multivariable model. That's why it's called as multivariable. And to calculate the effort, all of us know E is nothing but the effort per P by M, that is persons per month. And then you have D, that is that stands for duration. And here you will E is nothing but 5.2 cross L to the power of 0.91. So you are supposed to calculate the L, and D is nothing but the duration, 4.1 into L, 0.36. So by knowing what is given in the question, you substitute the relevant things in the formulas and get the outputs that we want. Okay. Now, so this is all about the two things, that is static, the single and the multivariable models for cost estimation. Now, moving to the Cocomo model. So here you're saying Cocomo model, this is nothing but first CO stands for, the first CO stands for constructor, the next CO stands for cost, and MO is nothing but the model. So this is called constructive cost model. So till before we have seen what is cost estimation, why do you require cost estimation, what are the two models associated with cost estimation, right? Now, to calculate the constructive cost model, that is the Cocomo model, that again involves the various things associated with the cost estimation. So the main purpose of this particular model, is to calculate the effort, right? We have so many formulas that we have discussed priorly. The effort, development time, the average staff size is average staff size is nothing but how many people are actually required in a project, how many people are actually there, and the productivity. So the main purpose of this Cocomo model, that is constructive cost model, is to calculate the effort, development time, average staff size, and the productivity. This model includes three things, that is the basic Cocomo model, the intermediate Cocomo model, and the detailed Cocomo model. So I repeat, Cocomo model is nothing but the constructive cost model. The main intention of this particular model is to calculate the effort, the development time, the average staff size, and the productivity. And in turn, this particular model includes three variations, that is basic Cocomo model, intermediate Cocomo model, and the detailed Cocomo model. So whenever you are trying to talk about this Cocomo model, first we have to check out whether it is discussing in the intermediate level or it is discussing in the basic level. So we will actually know what does basic and what does intermediate Cocomo model actually focuses on. Okay, now when you talk about this particular model, it is having a focus on three classes internally in a software project. What are those three classes? That is, it is considered as modes. First one is the organic mode. Second one is the semi-detached mode. Third one is the embedded mode. So I repeat, there is a too much of flow that is there. That is, initially we started off with Cocomo model, right? And that internally including three variations. That is the basic Cocomo model, the intermediate, that is the center, and the detailed Cocomo model. But when you talk about these things individually, that is, if I'm taking basic Cocomo model, again it involves three classes. What are they? They are nothing but the organic mode, the semi-detached mode, and the embedded mode. So in the same way, when I talk about intermediate Cocomo model, that again is having three variations, that is three modes, that is organic mode, semi-detached mode, and the embedded mode. So moving further, let us see what exactly this particular Cocomo model focuses on, its different modes, that is what is organic, what is semi-detached, and what is embedded. So these are the three classes under each category. Let it be basic, or let it be intermediate, or let it be detailed. So these three things have their own purpose. So when you say organic mode, so you can look at the diagram which is talking about the three classes that are towards the left side, that is the organic, the semi-detached, and the embedded. And you are focusing these three classes on four parameters. What are they? The project size, next the nature of the project, the innovation, the deadline of the project. Okay, so when you say organic mode or organic class, it is nothing but it involves 2 to 50 KLOC. That is nothing but 2 to 50 thousands lines of code. K stands for 1000. So 2 to 50,000 lines of code, 50,000 lines of code. Now, the nature of the project, when you because you can see the figure 2 to 50 only. So it comes under the small size project, and which involves the experienced developers. Okay, what type of things fall under this organic category? That is the payrolls and the inventory projects. That is different log related information. Those projects come under the organic mode. And when you say innovation, there is not much of scope, but okay, they are executing basing upon the things that they have. So it is termed as the less innovation. And when you say deadline, are there any deadlines for this organic class? No, you don't have any fixed or no deadlines, or it is not tightly saying that, okay, today you have to deliver this. That things are not there in this particular organic class. Now, moving to semi-detached. When you say semi-detached, it leads up to the project size of 50 to 300 KLOC. And this semi-detached comes under the medium-sized project, and it also holds medium-sized teams. And the example is the database systems. Okay. And innovations are also in the medium manner. And talking about the deadlines, normal, and it is not that tight. That is, if they specify some particular date, okay, there can be, if I say you have to deliver it tomorrow, if it's not done, okay, 2 days later or 2 days later. But there is no fixed date, you can say. So that is why it is considered as a normal for the semi-detached class or semi-detached mode. Coming to the third category, that is the embedded. This falls under this project size of above 300 KLOC. And this involves larger projects. Whenever you say larger project, obviously they are the real-time systems. So examples are ATM machines. Just an example like that, you can state so many other things. And innovations, significant, right? Significance meaning, yes, there can be innovations because it's a real-time applications. You can have a lot of updations, changes as the technology is advancing. We can have a lot of things done. And definitely the time is fixed and tight. That is, since it is a real-time application, that is, whenever you're taking up a government funded project or something, you can't say, I will, whenever I am free, I will do it. I cannot do it in this particular time. No, you have to deliver it on time. That is why it is considered as fixed or tight. So this comes under the embedded class. So moving further, yeah. Now, let us see some basic things or formulas related to basic Cocomo model, and how do you, suppose if some values are given, how do you calculate the effort, the development time, the people required, and all these things. So, to calculate the effort applied, the formula for a basic model, that is the first one, is nothing but A base 3 of the lines of code, KLOC, B to the power of B. That's the effort. How do you calculate? Next, you have development time. It is CD of the effort. Once you have calculated the effort, so you will substitute that in the development time. And required people is this one. What do you mean by required people? E by D. There is nothing but how much effort you are keeping by the development time. That gives us the required people or the average staff size for a particular project. And from the above formulas, you can consider all these to be coefficients, that is AB, BB, CB, and DB. Right. Now, if you are given some numerical formula problems on this particular topic, you will actually have a size given in this manner. That is, in the question itself, they will give you how much lines of code is there for that particular project. And using this particular table, we will be able to calculate, substituting them in the above formulas and getting us the outputs. So if you can look at the table, as we have seen priorly, a software project is involving 3 classes, that is organic, semi-detached, and embedded. And you have 4 coefficients, AB, BB, CB, and DB, where if you say organics, in the organic class or organic mode, 2.4 is taken by the AB coefficient, 1.05 by BB, and 2.5 by CB, and 0.38 by the DB coefficient. In the same manner, semi-detached, AB is 3.0, BB is 1.2, 2.5 is CB, and 0.35 is the DB for semi-detached. That is, you will have to substitute these values in the above formulas. And embedded mode, AB coefficient is 3.6, BB coefficient is 1.20, CB is 2.5, and 0.32 for DB. Okay, these are the values that have been given. Next. Okay, let us consider a small example of how do you substitute the values and how do you give us the cost estimation. So suppose if you are asked, suppose that a project is estimated to be 400 KLOC, right? Calculate the effort development time for the each of the following modes. So what is it saying? In the basic Cocomo model, you are having effort, the development time, the duration, how many people are there. The formulas have been shown to you. And basing upon the table of the coefficients that has been discussed, you just have to substitute the values and answer. So this, what is the size is already will be given to you in the question. So now let us start off. As we all know, basic Cocomo model equation is given. That is, the effort applied is E equal to AB of KLOC BB. And then development time is D equal to CB. That is, cost of effort of the coefficient. Now, estimated size project, it is given in the question itself that it is 400 KLOC. Now, he asked us to calculate the effort and the development time for each of the following modes. So, how many modes we have? We have organic mode, we have semi-detached mode, and we also have the embedded mode. So, coming to organic mode, we have the A, that is capital E, that is effort equal to AB of KLOC of BB. So now how am I getting this values 2.4 or 1.05? If you just go back, your AB in the organic mode is given a value of 2.4. So I'm just substituting here in the 2.4, and then KLOC already given to us in the question 400, and B to the power of B for the organic mode is 1.05. That lands up to 1295.31 P per M. That is nothing but persons per month. Persons per month. Right? Next, same way D equal to CB. So what is CB for the organic mode? That is nothing but 2.5. Substitute 2.5 into E value we have priorly got here, that is 1295.35, just substitute it here, and to the power of D, that is nothing but 0.38. So I substitute in this values and I will get this as 38.07 persons per month. So here for the organic mode, substitute in the relevant formulas. Next, you have semi-detached mode, same way, E equal to 3.0. So how are you getting this 3.0? Again, you can just refer, that is for the semi-detached mode, AB is 3.0. Then wherever you get BB value, just take 1.0, same way 2.5 and 0.35. So in this particular manner, you can substitute them in this relevant things. Like for semi-detached, you will get E, substitute the same value over here and you will get the development time. The third class, that is the embedded mode, you will have to substitute the same way, substitute this here. You will get the embedded mode. So this is how you calculate and find out the cost estimation under the category of basic Cocomo model. Right? Next, coming to intermediate Cocomo model. So when you say intermediate Cocomo model, it is nothing but extension to the basic model is the intermediate one. So in the table I have shown you what does the basic do, what does the intermediate do, what does the detailed one do. So moving from few parameters above the basic is the intermediate level. That is a slight kind of extension as it is told over here. Next, this particular intermediate mode is involving 15 set of additional predictors. Now, these predictors are called as cost drivers. So, this involves 15 set of additional predictors which are called as cost drivers. Right? Now, these cost drivers are again subdivided into various attributes. Right? Cost drivers adjust nominal cost of the project to actual cost of the project environment. So I repeat, intermediate Cocomo model is an extension to the basic Cocomo model. This is involving 15 set of additional predictors. Those additional predictors are nothing but the cost drivers. So they are also linked up to cost. Now what is this cost drivers? This cost drivers are adjusting the nominal cost of the project to actual project environment. So this cost drivers will help us to adjust the nominal costs to what? To adjust to the project environment. So cost drivers are trying to adjust the nominal cost of the project to the project environment. Now this 15 cost drivers are again subdivided into 4 attributes, right? Those attributes are product attributes, which are again subdivided into 3, or which are having 3 parameters to be discussed. Next, you are having computer attributes, which are again having 4 parameters to be discussed. The third one is nothing but the personal attributes, which are again having 5 attributes to be discussed. And then you have project attributes, which are having 3 things that are to be discussed. Right? So now let us see what are the 3 variations or 3 parameters involved in these 3 attributes. So I repeat, intermediate Cocomo model is an extension to the basic Cocomo model. This is involving set of 15 cost drivers. Now what are these cost drivers do for us? This cost drivers will help us to adjust the nominal cost of the project to the project environment. And they are again subdivided into 4 different attributes. The first one is the product attribute, which is having 3 functionalities. Next one is the computer attributes, which are having 4 attributes, 4 parameters discussed. And the third one is the personal attributes, which are having 5 things to be discussed. And finally is the project attributes that are having 3 things that have to be discussed. So moving to the first one, that is product attributes. So when you say product attributes, you have something called rely. Rely is nothing but required software reliability. How reliable is your software? The requirement is nothing but this rely. Next, the size of the data. In short, it is termed as the database size. And then you have complexity of a product. So it is CPLX, which stands for product complexity. These three things come under the product attributes. As I have told you, they have three things that has to be focused. Next, we have computer attributes, which talks about the time, which is called the time. It's nothing but the time constraints, how much execution time is required, or what are the various constraints required us to execute the things. That comes under this. Next, you have store, that is nothing but the storage things that have to be discussed. Then you have volatility, that is nothing but the VIRT, which is standing for virtual machine. And then you have turn, which is the turnaround time for a computer. Now, these four things will come under the computer attributes. So, moving further, you have personal attributes that are 5 in number, as I told you. The first one is the capability of the analyst. In short, it is written as ACAP, capability of the analyst. How much can he deliver us the things? Next one is the application experience. In short, EXEP, application experience. And then we have the capability of a programmer. So, programmer capability, PCAP. And then virtual machine expertise. How independent or dependent it is. That is V experience, that is nothing but the virtual machine experience. And then you have programming language experience, that is language experience, LEXP. So this 5 things comes under the personal attributes as stated before. Now we are done with 3 plus 4 plus 5, right? 3 was for the product attributes. 4 were for the computer attributes, and this 5 are for the personal attributes. And finally, we are left out with the last 3, which makes up to 15. And this last one is the project attributes, right? Now, under this, we have 3 things. MODP is nothing but the modern programming practices. Then tools, use of the software tools that are required. And the last one is SCED, that is the development schedule time, or the required development schedule. That's nothing but the last one, that is the project attributes. Okay. Now, each cost driver is rated for a given project environment. Now, we have seen this 15 cost drivers. What are these cost drivers trying to help us? They're trying to adjust the things to the real-time environment. They again are rated in the following manner. In what ways are they rated? Very low, low, normal, high, very high, extremely high. These are like the factors on a scale of 0 to 10, 0 to 15. How do you rate them? It's like for the cost drivers, we rate them in this particular manner, right? Now, to calculate the intermediate Cocomo model, here again, you have another formula for the effort, which states AI of KLOC, that is the lines of code of BI, to EAF. Now, EAF stands for effort adjustment factor. Now, why are we using this term called adjustment? Because cost drivers are used for adjusting based upon the present environment. So, EAF is nothing but the effort adjustment factor. Now, once this EAF is known, you need to substitute them into the relevant things where AI and BI are again coefficients where the values will be given. KLOC also will be given in the question itself, and then you will calculate the EAF, right? EAF will be given in the things. EAF will be given, K lines of code will be given, AI and BI are the coefficients that we will be taking it from the table. Next, the development time. How do you calculate the development time? The product of cost and effort. So this is a table that is needed for you to take the values of AI, BI, CI and DI as we have seen for the previous models. Just substitute the values for the organic mode, semi-detached mode and the detached mode. Okay. So EAF and KLOC will be given in the question basing upon the formulas that have been stated priorly for the effort and the development time, taking these values in the relevantly. Suppose if you say organic in the intermediate Cocomo model, you are talking about the organic class. Then substitute the relevant things. If you are having EI, take the value of EI, BI, take the value, CI, take the value as 2.5, D value, take the value as 0.38. Similarly to these two things as well, as shown priorly. Next, EAF. What does this do? This can be calculated by multiplying all the values that have been obtained after categorizing each cost driver factor. So initially you will be given EAF value. If you don't give, if you are not given EAF values, you can multiply all the values of the cost related for each cost driver. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.